This is the Halo Longsword. So like 2 weeks ago, we did the Halo Pelican. We found that it was quite draggy and it was producing a lot of negative lift, like minus 0.5. Check out that video as well. So with this one, this is a significantly different aircraft. It's a lot more streamlined, a lot slimmer. And I've done this video with some streamlines going from left to right. So we can see them going over the aircraft. And you see that first up, there's almost a very little wake. Like first of all, it converges very quickly, the streamlines, and they're not really going in this weird fashion out afterwards. And that just continues over the rest of the aircraft. Now the Halo Pelican, as I said, produces a lot of negative lift. This one produces almost nothing, like it's minus 0.05, so it's almost zero. And so that means that like the flow is going over the object and then it just reattaches, like there's no real separation, and it just takes up that weight quite well. So these are arrows showing how the flow is moving, and we're going to go going through the plane, through the aircraft. And you can see like everywhere that you see, the arrows, they go over a surface, but then they converge very quickly. So that's what reduces the wake, and this is a lot less draggy than the Halo Pelican. And this is the magnitude going through the object, through the aircraft, so you can see how the flow is accelerating and decelerating over it. And so, for example, just here, we're going over a wing. You can see that the flow is accelerating over both sections. That's why we're not really producing much lift. And the wake, again, is not that big. It's just a very small section. It wasn't like the Pelican at all, where the Pelican had like this massive wake behind. And even still, this is traveling at the velocity of 30 meters per second free stream. And even like in this, the worst part of the wake, it's still above 20 meters per second. So it's pretty good. This is the UZ velocity. So blue is going down, red is going up. And I plotted this because I wanted us to just see what the flow is doing in this direction over the aircraft. And it's effectively what you would expect. Like when it goes over the surface, it either has to move around, so it either goes high or low. But afterwards, you can see there's almost no wake, because like in the exit direction, at least, because the flow is not really moving up or down. It's just still continuing with the rest of the free stream velocity. And this one is a plane going through the Z, so going from the bottom of the aircraft up, and we're plotting the UX, which is the X velocity. And I think that this is a pretty good angle because it shows you just how small the wake is. I mean, now we're hitting the aircraft and it's not very big at all. Once you get like one longsword length downstream, it's almost the same velocity as the free stream. The wake has really died out very quickly. And then this is a cool part here where we're now just over the aircraft, and you can see these very red regions. They're the regions where the flow is really accelerated over the top, but because the flow is accelerated so much underneath as well, the lift really cancels out. And I plotted this picture here. It shows the streamlines, and the reason why this is an interesting picture is because I put the streamlines directly on the leading edge. So some are going over the top. This is the top here, and there's some going underneath. And the reason why this is an important picture is because it shows just how much the streamlines are diverging or converging. If you have something producing lift, usually the pressure side, so in this case, it's actually the top side because it's producing negative lift. These streamlines, if it's producing a lot of lift, should be diverging. They should be going out to the sides, so towards the wings, because you have this pressure differential between the two surfaces and this roll up happening on this higher pressure flow bleeding over to the low pressure flow. But you don't have too much divergence or convergence from any of these streamlines. So that shows that there's very little lift being produced on this aircraft at zero angle attack. Right, so that's this video. Make sure to check out the Atmosphere Hawk. It makes all your aerodynamics better. It gets rid of a lot of errors for you. Check out our courses that we run, and check out the International Aerodynamics Conference. It's a conference that we're running in October every year, and you're welcome to come.